Now the screen is visible to everyone. The screen is visible to
Yes,
everyone
sir.
or not? Thank you. So in today's class, we are going to deal with characteristics and performance of transmission lines. So 10 to 12 questions we may discuss in this session. So the first question is the surge impedance of a three-phase 400 kV transmission line is 400 ohms. The surge impedance loading is, you have option A 400 megawatts, option B 100 megawatts, and option C 1600 megawatts, and option D 200 megawatts. So we have to find out surge impedance loading for the system given in the question. So the information given is it is a three-phase system. The voltage rating is given, it is 400 kV, and then transmission line impedance is given 400 ohms. So a simple relation we have. So the surge impedance loading SIL, surge impedance loading is nothing but SIL. The relation which is available is V square rated by ZC. So this is the standard relation. So V square rated is nothing but 400 kV. Plus 400 into 10 cube the whole squared divided by 400. So you may have answer in terms of megawatts. So that is the correct option. I hope it is clear to everyone. Surge impedance loading relation is V square rated by ZC. V rated is 400 kV. So 400 into 10 cube the whole squared by ZC is nothing but impedance available in the question. So 400 substitute in the equation and you may get answer in terms of megawatts. So what do you get? Answer சொல்லுமா நான் பேசுறது கேக்குதா? My voice is audible or not?
Yes, sir.
Okay ma. Answer சொல்லுங்கம்மா.
Sir, 1000, sir.
என்னம்மா?
1000.
400 megawatts வருதும்மா answer.
Sorry, sir. Sorry, sir.
400 megawatts. Option A is the right answer. 400 megawatts. Your option A is the right answer. Option A is correct. I'll move on to the second question. For trans, which one of the following relations is true? You have four relations in front of you. So first one is AD minus BC equal to 1. Option B minus AD minus BC equal to 1. Option C AD minus BC equal to minus 1. And option D AD minus BC equal to 0. So which of the following relation is true? Depends upon the transmission line. So it is nothing but your parameters, transmission line parameters, A parameter, B parameter, C parameter, D parameter. So in transmission line parameters, we may aware of these values. We know the constant A value, we know the constant B, and we know the constant C, and we know the constant. So which relation is true? So we know reciprocity in transmission line. So reciprocity is nothing but from reciprocity. From reciprocity, we know the matrix A, B, C, D equal to 1. So we may write the relation as AD minus BC equal to 1. So the option A is correct. Based on the reciprocity concept in transmission line, we have the matrix A, B, C, D equal to 1. I may write the determinant as AD minus BC equal to 1. Option A is correct. Option A is correct. Third question. If D is the distance between conductors and R is the radius of conductor, the inductance of a single phase two-wire line is given by D is distance, R is radius of the conductor. Here we have to estimate what is the inductance in single phase two-wire line, whether A, B, C, or D. A is 0.4 ln capital D by small r millihenry per kilometer. The option B is 0.55 ln D by r millihenry per kilometer. And option C is 0.4 ln r by D millihenry per kilometer. And option D is 0.55 ln r by D millihenry per kilometer. So if we aware of single phase transmission line inductance calculation, it is easier to find the answer. So what is the expression we have for single phase two-wire transmission line? L equal to 4 into 10 power minus 4 ln D by square root of R1 dash R2 dash. So this is the standard relation we have for single phase two-wire transmission line. So for theoretical cases, we may equate R1 dash R2 dash as R. So in this case, the question is given as R is the radius. By just equating the we have in single phase transmission line, you have two wires. One is your line, another one is neutral. So usually for line radius is R1 dash and neutral is R2 dash. So they are simply saying these two are equating to R. So அப்போ பாரு என்ன கிளியரா வரும்னா 4 into 10 power minus 4. அப்போ 0.4 சொல்லலாமா? 0.4 ln D by R into R. ரூட்ல இருக்கு R square இல்லையா? While we taking R square, square root of R square is nothing but R. So 0.4 ln D by R millihenry per kilometer. Option A is the correct answer. So if we are aware of calculation of single phase inductance calculation, it is easier to find out the answer. So option A is the correct answer. Is it okay to everyone? Is it okay to everyone, or you need any clarification? Yes. The fourth question. Under no load conditions, the current in a transmission line is because of option A capacitance, option B corona, option C proximity, Option D, backflow from earth. So under no load current, the current in transmission line is because of which effect? Under no load condition, the current in a transmission line is of option A, capacitance, option B, corona, option C, proximity, option D, backflow from earth. Any guesses for this answer? Why in no load condition we have a current in transmission line? What is the reason? So one effect is involved in it in transmission line theory. Okay, I'll clarify you. So under no load condition, in no load condition, your current is flows due to your capacitance. So this effect is known as Ferranti effect. So Ferranti effect is also known as capacitance effect. Both are same. So option A is the right answer. The no load condition, your current is flowed with the help of your capacitance because you have the charging process due to your capacitor process. So it is due to your Ferranti effect. It is also known as capacitance effect. So option A is the right answer. Under no load condition, the current in a transmission line is because of capacitance effect. Remember, capacitance effect also is known as Ferranti effect. Based on Ferranti effect and SIL, you may get 2 to 3 questions in each and every gate examinations. Minimum minimum 1, maximum 2 questions from SIL, Ferranti, Corona. From these definitions, you may have questions. So remember the definitions of Corona effect, Ferranti effect, proximity effect, and surge impedance loading. Based on the 4 relations, you may have problems or theory-based questions. Question number 5. When the load on a transmission line is equal to surge impedance loading. So we have to select which condition is correct. So receiving end voltage is less than the sending end voltage. Receiving end voltage is less than, sending end is less than receiving end voltage. Receiving end voltage is equal to sending end voltage. And D, none of these. So in which effect the receiving end is equal to sending end voltage? Yes. Transmission line is equal to surge impedance loading. At which phenomenon these things happened? So transmission line, when a load on a transmission line is equal to surge impedance loading. So at which circumstances this is possible? Whether receiving end is less than sending end, or sending end is less than receiving end, or receiving end sending end equal, none of these. So you know the definition of surge impedance loading. So when a load on a transmission line is equal to surge impedance loading, the receiving end voltage is equal to sending end voltage. So this is the definition of SIN. So option C is the correct answer. The sending end and the receiving end is equal. So this is your definition of surge impedance loading. So next question is based upon your Ferranti effect. If you are aware of Ferranti effect, it's easier to answer. Which of the following statement are correct? A flow of unduly heavy current is Ferranti effect. Ferranti effect occurs under unloaded condition of line. The rise in receiving end voltage is Ferranti effect. And option D, both B and C combined is Ferranti effect. Yes. So the question is open to you. You may answer. So you have to pick which option is correct. Whether A option, B option, C option, or D option. I already discussed about your Ferranti effect in the second question or third question. Yes, fourth question. Under no load conditions, the current in transmission line because of capacitance effect are also known as Ferranti effect. Okay. Based on that, you have the option 6. Sorry, question number 6. Yes. Based on the definition of Ferranti effect, Ferranti effect occurs under no load condition due to capacitance of line. So it causes your receiving end voltage to be more than sending end voltage. VR should be more than your sending end. So this phenomenon is known as Ferranti effect. இது வந்து எந்த ஆப்ஷன்ல கரெக்டா இருக்குன்னு பாத்தீங்கன்னா Ferranti effect occurs under unload condition of line. அது ஒரு ஆப்ஷன் கரெக்ட். The rise in receiving end voltage, receiving end வந்து sending end ஓட அதிகமா இருக்கும், is Ferranti effect. So both B and C are correct. So option D is the correct answer. Both B and C combined is Ferranti effect. So this is known as Ferranti effect. Option D is the correct answer. Question number 7. A single phase line is transmitting 1100 kilowatt power to a plant at 11 kV and a 0.8 power factor lagging. It has a total resistance of 2 ohms. Transmission efficiency of the line is 97.24 percentage, 3.873 percentage, 28.5 percentage, or 98.21 percentage. So we have to find out what is the transmission efficiency of the line. We know the power in kilowatts is given 1100 kilowatt, and the rated kV value is 11, and rated power factor is 0.8 lagging, and resistance in the transmission line is 2 ohms. So based on this information, we have to find out what is the efficiency, transmission efficiency. So simple relations we have to solve this problem. Yes, first of all, we have to find out our load current I. So I is nothing but your power, that is 1100 kilowatts. So into 1000 divided by your kV. kV is 11 kV. So 11 into 1000, 11,000. Power factor is 0.8. 0 cancel down, 0 cancel down. 11 divided by 11 into 0.8. So you may get current as 125 amperes. Check whether you got 125 amperes or not. Whether 125 is correct or not. One 25 correct, amma. எல்லாரும் Hmm. 7 or 10 is so you may get 125 amperes. The current is 125. The next one is we have to find out what is the loss. Loss we know that I square R. 125 squared. Resistance is 2 ohms. So probably it is 31.25 kilowatt. So this is your loss. So we know the value for I and losses. I is 125. The loss is 31.25 kilowatts. So we need transmission efficient. E out by P out plus P loss into 100. So 1100 by 1100 loss is 31.25. Both all the values in kilowatts into 100. So you may have answer in terms of percentage. So approximately you may get 97.24%. So option A is the correct answer. So option A is the correct answer. So next one is, it is a statement based question. Question number 8 and 9. A single phase 60 hertz transmission line and a telephone line both are supported on a horizontal cross arm in the same horizontal plane. So in the same plane, you have a transmission line as well as a telephone line. The spacing between line conductors is 2.5 meter. And conductors of telephone line are of solid copper spaced is 0.6 meter between centers. So the distance between nearest conductor of line is 20 meters. A current of 150 amps is flowing over the power line. So two questions we have to solve based on this data. The value of mutual inductance between the circuits. We have 4 options. We have to estimate that one. And option 9th question, what is the value of voltage per kilometer induced in the telephone line? So these two questions we have to solve based on the statement. So first of all, we have to understood the question. So what is actually presented in the question? We have two scenarios. So one is your transmission line. Another one is your telephone line. both are arranged in a horizontal cross. I just draw the diagram. So this is your transmission line. So from center to center, spacing is 2.5 meters. I can say this is your conductor A, this is your conductor, and here it is positive current, here you have negative current. So 2.5 is the spacing from center to center. So one more information about your telephone line. So telephone line, it is also two conductors, namely T1, T2. So in between the center, you have the spacing of 0.6 meter. 0.6 meter. From B conductor or A conductor, or from B to T1 or A to T2, you have the separation in a horizontal plane. You have the separation of 20 meter. So this is the actual representation of the transmission line and telephone line. இதுதான் கொஸ்டின்ல கொடுத்துருக்காங்க. ஸோ இதுக்கு வந்து நம்ம மியூச்சுவல் இண்டக்டன்ஸ் கண்டுபிடிக்கணும் ஃபர்ஸ்ட். செகண்ட் வந்து த வோல்டேஜ் இன்டியூஸ் இந்த டெலிஃபோன் லைன், ரெண்டுத்தையும் கண்டுபிடிச்சோம்னா இட் இஸ் first question based on the statement, the value of mutual inductance between the circuit. Option A வா B ஆ C ஆ அப்படின்றத செக் பண்ண போறோம். ஃபர்ஸ்ட் வந்து பாத்தீங்கன்னா இண்டக்டன்ஸ்க்கு we need flux linkages. Flux linkages in the telephone line கண்டுபிடிக்கணும். So flux linkages of conductor T1 due to flux between conductor A and B. இது நம்ம டெரிவேஷன் நடத்தும் போது நான் நடத்திருக்கேன், நான் டி எடுத்தவங்க தெரிஞ்சிருப்போம். lambda T1 equal to 2 into 10 power minus 7 I into ln D2 by D1. So 2 into 10 power minus 7 is a constant. I is nothing but your current 150. Ln D2 is 20 meter on the spacing. D1 வந்து பாத்தீங்கன்னா from A to T1. So A to T1 you have the total distance of 22.5. So once you solving, you may have 0.353 into 10 power minus 5 Weber turns per meter. So this is your first linkages between conductor A and B. Next one is a flux linkage of conductor T2 due to flux between conductor A and B. That is second flux linkage we have to calculate. So lambda T2, that one is lambda T2. So 2 into 10 power minus 7, current வந்து 150, ln இப்போ வந்து உங்களோட right hand side. So from V to T2, you have 20.6. And then the total one. So total distance is 23.1. So 2.5 plus 20 plus 0.6. So 23.1. So you may have the flux linkage with respect to T2 is minus 3.43 into 10 power minus 5 Weber turns per meter. So the resultant flux linkage should be lambda T1 minus lambda T2. So once you taking average of these two, you may have minus 0.01 into 10 power minus 5 Weber turns per meter. So we need mutual inductance of the conductor. So L is nothing but, so the value is negative, we have to convert into positive. In transmission line, in case of telephone line, we have to convert negative into positive. So 0.01 So 10 power minus 5, sorry, 0.01 10 power minus 5 by 150 into 10 cube millihenry per kilometer. So this is the standard relation we have. Only the del value we calculated. Rest of the values and current. Rest of the things are constant. So L is 0.00067 millihenry per kilometer. So option B is the correct answer. The ninth question. So what is the value of voltage per kilometer induced in the telephone line? Either A option, that is 0.01729, or option B 0.04552 volt per kilometer, option C 0.0314 volt per kilometer, and option D 0.0377 volt per kilometer. We have to pick the right one. We have the standard relation. So induced voltage in a telephone line is 377 into your inductance. So inductance, sorry, not inductance, that is your flux linkage del T. 0.01 into 10 power minus 5 into 10 cube. So you may have 0.0377 volt per kilometer. Hence option D is correct. Based on the statements, you have questions like this. Based on telephone line and transmission line, you have questions. You need to refer IJ Nagrath and Kothari book of this theory. இது மட்டும் நான் அந்த நகராத் கோத்தாரி புக்ல உங்களுக்கு எடுத்திருப்பேன் கிளாஸ் எடுக்கும்போது. பழைய நோட்ஸ் இருந்தா செக் பண்ணி பாருங்க. ஃபைனல் இயர்ஸ்க்கு தெரியும், தேர்ட் இயர்ஸ்க்கு நீங்க உங்களுடைய விகே மேத்தா புக் பாருங்க, அப்படி இல்லைன்னா நகராத் கோத்தாரி புக் பாருங்க. So 10th question. Transposition of transmission line is done to reduce line loss, reduce skin effect, balance line voltage drop, and reduce current. Why transposition of transmission line is needed? You have 4 options. Pick the right one. Whether it is line loss, or reduction of skin effect, balancing line voltage drop, and reducing corona. Usually in a 3-phase transmission line, unsymmetrical spacing causes your flux linkages, and so the inductance of each phase to be different in order to receiving your unbalanced voltages, unbalanced receiving end voltages. So your sending in voltages and line currents are balancing, you have the problem. So due to this inconvenience, transposition is done. So our own intention of transposition of transmission line is done to balance line voltage drop. We have to balance your sending voltage, receiving your voltage as equal. We have to use transposition of transmission line. So option C is the correct answer. If you have any queries, means you may interrupt in the middle and ask. If not, means listen. For a given transmission line, the expression for voltage regulation is given by Vs minus VR by VR into 100. Hence, you have four options. This must be a short transmission line. Option B, this may either be a medium line or a short line. This expression true for any line. This may either be a medium line or long line. So you know the voltage regulation expression in your machine as well as transmission line, both are same only. So in machines you are no load, full load you have. In transmission line we have sending and receiving. But the regulation remains same for all the electrical parameters. So Vs minus PR by VR into 100. So which line it is applicable? Either short line, medium line or long line. So in which transmission line is applicable? So you know that. So in short transmission line, your VR full load equal to VR and VR no load equal to Vs. So in short transmission line only it is possible. The rest of the medium and long transmission line it is not possible. So this percentage regulation is only applicable in your short transmission line. So for option A is correct. This must be a short transmission line. So option question number 12. In the case of characteristic impedance of a transmission line is equal to load impedance. So you have four options. The system will resonate badly. All the energy sent will be absorbed by the load. Option C, all the energy sent will pass to earth and all the energy will be lost in transmission line as transmission losses. So which statement is applicable to the characteristic impedance of transmission line is equal to load impedance? Assume the scenario if the line is terminated in its characteristic impedance. The refilled voltage is 0. So if the line is relieved from its impedance means obviously your voltage is 0 because it is open circuited. So in this case, all the energy sent will be absorbed by the load. So your entire thing should be absorbed by the load. So it is also called as infinite line. So option B is correct. All the energy sent will be absorbed by the load. Option B is it is homework for you. A telephone line is in parallel to a untransposed three-phase 50 Hz transmission line as shown in figure. The current flowing through power line is 400 amps per phase. The voltage induced in the telephone line per kilometer will be. So இதே எக்ஸாம்பிள் நம்ம இப்போ சால்வ் பண்ணோம் இல்லையா, இதே மாடல் தான். நீங்க வோல்டேஜ் இன்டியூஸ்ட் பர் கிலோமீட்டர் மட்டும் கண்டுபிடிச்சா போதும். அதே சேம் பேட்டர்ன். ஸ்டேட்மெண்ட் கொஸ்டின் சால்வ் பண்ணோம் இல்லையா, அதே போல தான். ஸோ அங்க வந்து சிங்கிள் பேஸ் லைனும் டெலிஃபோன் லைனும் கொடுத்துருந்தாங்க. இன்ஸ்டெட் ஆஃப் தட் த்ரீ ஃபேஸ் பவர் லைன் அண்ட் டெலிஃபோன் லைன். ஸோ த்ரீ ஃபேஸ்க்கு வி ஹாவ் த ஸ்டாண்டர்ட் ரிலேஷன். ஒரே ஒரு ஸ்டாண்டர்ட் ரிலேஷன் இருக்கு. ரெண்டு ஈக்குவேஷன்லாம் வேண்டாம், ஒரு ஈக்குவேஷன் இருந்தா போதும். டெல்டி தட் இஸ் 2 × 10⁻7 I ln dA2 by dA1 plus ln dB2 by dB1 and ln dC2 by dC1. So that is the net flux linkage of the telephone line. So you may calculate your lambda t. So once lambda t is calculated, you may get for lambda T by current into 10 power 6. You may get inductance in terms of millihenry per kilometer. So once you calculated your inductance, we may easily calculate voltage induced in the transmission line. So for three phase, it is 314. In single phase, we may calculate as 377. But in case of three phase, it is 314. So the lambda value 0.0176 into 10 power minus 4, 10 cube at an angle 140. So finally, you got 0.553 at an angle 140. இது ஹோம்ஒர்க்கா பண்ணுங்க. சொல்யூஷன்ஸ் உங்களால போட முடியல, நான் அடுத்த கிளாஸ் சால்வ் பண்றேன். It's for homework. Take a snapshot of this test homework. So option B is correct. Check whether you have got B correctly or not. Yes. Skipping 14th. We may try to solve in the next class. Equivalent pi model is quite suitable for analyzing performance of transmission line. So 50 kilometer length, 150 kilometer length, 250 kilometer length, all of the above. So equivalent pi model is quite suitable for analyzing performance of transmission line. 50, 150, 250 kilometer length on all of them. So here in that answer key, they are mentioning 250. In point of view of VK Mehta, we may restricted 100 kilometers or more than 50 kilometers. But it is quite reversed. Now VK Mehta on 30, 40 years back text. They are recently revised the transmission line modeling. So 25 kilometer length is applicable for your pi model. So option C is correct. 25 kilometer or more than that, we have nominal pi is suitable. In place of your long transmission line, pi is suitable. Because in pi method, your transmission losses are much negligible. So most of your transmission systems are nominal pi method only. And question number 16, the charging current in a transmission line increases due to corona effect because corona increases. Why corona is increases? Either line loss, effective line voltage, or power loss on lines, or the effective conductor diameter. So once the corona induces harmonic currents, which causes the charging current to be increases. So obviously, power loss on lines is the main source of corona. So due to your charging current. So option C is correct. Power loss on lines, you may infer corona. I'm sorry. Yes, line current. Increasing of your line current, you may get corona, not a power loss because of your line current. Yes, rest of the things we may discuss in the next class. So you may have statement questions. We may discuss in the next class. Thank you all.